Hello, everybody. Welcome to a smart grasp, explore, and win. Greetings for the day. Let's get started with today's topic.
Chapter 5 Understanding Elementary Shapes, Exercise 5.6. In that, first sum. Name the types of following triangles, and we have few subdivisions. The first subdivision is triangle with lengths of sides 7 centimeter, 8 centimeter, and 9 centimeter. So here the sides of the triangles are different from each other. That is, all the three sides are unequal. No side is equal to the other side. 7, 8 and 9. So the three sides of the triangle are of with different measures. Hence, it is a scale-in triangle because scale-in triangle only has three unequal sides. B sum. Triangle ABC with AB equal to 8.7 centimeter, AC equal to 7 centimeter and BC equal to 6 centimeter. Here also all the three sides are different. They are not equal in any way. Hence, it is a scale-in triangle. See some triangle PQR such that PQ equal to QR equal to PR equal to 5 centimeter. That is, all the three sides is 5 centimeter. If all the sides of a triangle are equal, then it is a equilateral triangle. Now, D sum triangle DEF with angle D equal to 90 degree. That is, we have triangle DEF in which the angle of D is 90 degree. So we have one of the angles as 90 degree. Then it is a right angle triangle because we know that right angle triangle has one right angle. So they have given only one of the angle as 90 degree and they didn't mention anything about the sides. Hence, it is a right angle triangle. Now, in the E sum, they have given triangle XYZ with angle Y equal to 90 degree and XY equal to YZ. So now here, they have given one of the angle as 90 degree. So it should be a right angle triangle. Also, they have given one more condition as xy equal to yz. That is, two sides of the triangle are equal. When we think about which triangle has two of its sides are equal, then we got the answer as isosceles triangle. So in the E sum, it is a combination of a right angle triangle with isosceles triangle because right angle triangle has one of the angle as 90 degree and in isosceles triangle, two sides are equal. Hence, it is a right angled isosceles triangle. Now, F sum triangle LMN with they have given three different angles. Angle L 30 degree, angle M 70 degree and angle N 80 degree. All the three angles are acute angles. Hence, it is a acute angled triangle. Now let's move to the second sum. Here it is a match the following. In the left hand side they have given the measures of a triangle, whereas in the right hand side they have given the type of triangle. So we are going to match accordingly. The first subdivision, three sides of equal length. A triangle which has all of its sides, all the three sides in equal length is equilateral triangle. So for any equilateral triangle, all the sides are equal. We have already discussed about this in the first sum as well. So here the option E. For the first one, it is option E. Second one, two sides of equal length. So for isosceles triangle, two sides are equal. This also we have already discussed in the first sum as well. So the answer is option G. Third subdivision, all sides of different length. That is, all the three sides are unequal. They are not equal in any way. This also we have discussed in the first sum. The answer is scale-in triangle. That is option A. Now, moving on to fourth subdivision, three acute angles. That is, all the three angles of the triangle should be acute angle. So we have the option F here, acute angle triangle. Fifth subdivision, one right angle is right angle triangle. and we have one obtuse angle, then it is obtuse angled triangle, option C. Now the last one is one right angle with two sides of equal length. Similar to this sum, that is, it has one right angle and the two sides of that triangle are equal to each other. So in that case, it is a right angled isosceles triangle. That is option B, isosceles right angled triangle. So now let's move on to the third sum. Third sum, name each of the following triangles in two different ways. You may judge the nature of the angle by observation. So it is a hint given. On naming a triangle, we can name it by two ways. The first one is by observing the angles, and the second one is by observing the sides given. For example, observing the angles, we can say right angle triangle, acute angle triangle, obtuse angle triangle, and so on. And observing the sides, we can say equilateral triangle, scalene triangle, isosceles triangle, and so on. So that is the difference. So now let's try to name these by two ways. So in the first subdivision, let's look into the sides first. 8, 5, 5. That is, two sides are equal. Then it is an isosceles triangle because in isosceles triangle only we have two sides of equal length. So on observing the sides, it is a isosceles triangle. Now let's observe the angles. When we try to observe the angles, all the three angles are acute angles. So acute angle will be in this shape, that is, it will be little closer. The two rays will be little closer. But if it is obtuse, the two rays will be far apart. That is, they will be far apart than 90 degree. The rays in the angle for acute will be closer, but for obtuse it will be far. So on observing here, all the angles are acute angles. So acute angled triangle, and it is isosceles triangle. So we have named it on the basis of side as well as on the basis of angle. Now second subdivision, let's look into the angle. We have one right angle there. So it is a right angled triangle. On observing the angle, we have named it. Now on observing the side, we have 17, 8, 15. All the three sides are of different length. Then it is a scalene triangle because scalene triangle only has three different lengths. None of the sides will be equal to any of the sides in a scalene triangle. Now, third subdivision, let's look into the angle. The rays that forming the angle are far apart. Hence, it is a obtuse angle triangle because for acute angle, it will be close. Since it is obtuse angle, they are far apart. Now, on observing the sides, we have 7, 7. Two sides of this triangle are equal. Then it is a isosceles triangle because for isosceles triangle only two sides are equal. Fourth subdivision, here we have a right angle, hence it is a right angle triangle. Now sides, we have 10 centimeter, 10 centimeter. If both sides are equal, that is, if two sides of a triangle are equal, then it is a isosceles triangle. Fifth subdivision, let's look into the angle. On observing all the angles, looks like acute angle because the rays are closer to each other. Therefore, it is a acute angle triangle. On observing the sides, all the sides are equal. Then it is a equilateral triangle. Last subdivision. On looking into the angle, the rays forming the angle are far apart. Hence, it is obtuse angle triangle. On looking the sides, all the three sides are unequal. They are different. So it is a scalene triangle. So it is a scalene triangle. Now let's discuss the fourth sum. Fourth sum. Try to construct triangles using matchsticks. So using matchsticks, we are supposed to construct triangles. Some are shown here. So they have given some examples. Can you make a triangle with 3 matchsticks? 4, 5, 6. Remember, you have to use all the available matchsticks in each case. So in each case, we are supposed to use all the matchsticks and form a triangle. Name the type of triangle in each case. So in each case, we are supposed to name the type of the triangle as well. If you cannot make a triangle, think of reasons for it. If at all we couldn't make a triangle, we are supposed to mention the reasons for it. So the first subdivision is 3 matchsticks. It is very easy and simple to construct using 3 matchsticks. One, two, three. Now on observing this, there are 3 matchsticks has been used. 1 matchstick in each side. That is 1, 1, 1. So each side we have single matchstick. Hence, it is an equilateral triangle because the number of matchsticks in each side is equal to each other. So it is an equilateral triangle. Next subdivision is 4. So using 4 matchsticks, they are asking us to construct a triangle, which is not possible because we already know that sum of two sides of a triangle should always be greater than the third side. We can compare that in the given example as well. Here, let's say this side we have 2 matchstick and here it is 1 matchstick. So 2 plus 1 is 3. Sum of two sides, that is 3, is greater than the other side, the third side, which is 2. Obviously 3 is greater than 2. We can try up this in any combination. You can take any two sides of this triangle, sum it up, it will always be greater than the third side. Whereas while using 4 matchsticks, this theorem is not possible. Hence, it is not possible to construct a triangle. So let's write by using 4 matchsticks, we cannot make a triangle. Since we know that sum of the lengths of any two sides of a triangle is always greater than the third side. So this theorem is true, hence we cannot satisfy this theorem using 4 matchsticks, therefore it is not possible. Now 5 matchsticks, it is already in the example. So 1, 2, 3, 4 and 5. So yes, this is possible. Now we have 2 matchsticks here, 2 matchsticks here, and we have 1 matchsticks here. So these two sides are equal. If two sides of a triangle are equal, then it is a isosceles triangle. So it is an isosceles triangle. Now D subdivision, 6 matchsticks. We can just modulate this sum itself. 1, 2, 3, 4, 5, 6. So all the sides we have 2 matchsticks. If all the sides of a triangle are equal, then it is a equilateral triangle because all the sides we have 2 matchsticks. So all the sides are equal. If all the sides are equal, then it is an equilateral triangle. With this, we have completed this exercise.
Thank you all for watching Smart. Grasp, explore, and win. Stay tuned for more videos.